Did you try to work on the move disk recursion function? Yeah, no matter you finish that or not, that's a good start to think. So before I show you how to implement the move disk function, let's see and review our recursion function characteristic first. Remember, we always need to have a base case. So you need to think about earlier our move disk. Which one is the base case? Yeah, actually the base case we didn't show you here. The base case is what? The base case is 1. So if you have n equal to 1, do you know how to move that one disk? Right, you know, right? You just move that disk from the front tower to the 2 tower. So that one will be our base case. So that base case is when n equal to 1, we just move that disk from front tower to the 2 tower. So then we will have the if-else statement to lead to the different cases. If n equal to 1, so we just move that disk. Otherwise, if n not equal to 1, right, that's what we need to do. We just need to call our recursive function again to pass the argument. So the argument, not n, will be n minus 1. So the front tower still the same, but the 2 tower will be different because the 2 tower we need to using the assistant tower become the 2 tower. Then the assistant tower from the original one will become the 2 tower. So that's we will call the n minus 1 passing the value to the recursion function. So then you see we can just move the disk n from A to B. Then I call the recursion function again, passing n minus 1. So that's our recursion function, the concept, how we implement that. When we review the recursive function characteristic, the first thing, right, we do have the if-else statement. Our if condition is n equal to 1. That will be the base case. So I just move the disk 1 from front tower to the 2 tower. Then if not, the else will be the recursive function call. Actually, we have 2 recursive function call. The first one is n minus 1. Then I move the disk n from front tower to the 2 tower. Then I call the recursion function again. Of course, here I only show you the concept, right? Then let's really see how we implement that function. So that function, just like earlier we say, our recursive function called move disk. You have 4 arguments. The first argument is how many disks. The second argument is the front tower. We're just using a character to display that. Then we need to pass the 2 tower and the 6 tower. So in this function, they won't return anything. So they will be the void function because we only display some information. So then you have the if-else statement for the base cases or different cases. Right, so our if statement is n equal to 1. So if your n equal to 1, actually we don't do anything. I just need to tell the user how to do the move. So then we do the cout. Yeah, because this code actually came from my Java class. So that's why you will see that's Java syntax. So now here, actually, if the base case, right, I just need to move the disk 1. Of course, the disk 1 is n. When n equal to 1, I move the disk n. So then from is the syntax. Then your front tower is argument. So that will be the variable name. So then you move your disk n from front tower to the 2 tower. So that's our base cases. Because here we don't return anything. Because our goal when we implement the move disk function, we just want to guide the user how to move the disk one by one. So we just display our result. So if you have your n actually only equal to 1, do you know how to move the disk? Right, very easy, right? So that's why you just cout to the console. You say move disk 1 from front tower to the 2 tower. Otherwise, what happened? So right, if not, then we will do what? So if else, actually we have 3 things to do. So if that else, right? Okay, so think here, I think I'm missing the close bracket. So if not, I need to call the function again. So I call the function again, but this time I only move n-1 disk. So then my front tower is still from the same location. But my destination is not to the original 2 tower for the n. We will go to the assistant tower using the other 2 tower as assistant. So that's why you can see here will be the recursion function code. So that's recursive function code. So of course we need to do twice. Also we do the second one later. But that's finished. So after you call the recursion function code past n-1, right? So right, remember we told you. Then the other thing is we move n-1 to the assistant tower. Then I just need to move the disk n from A to the destination, right? Right, so that's why here, the second one actually I just display my result. So again, yes, here using the C++, so that's C out. Okay, so you move disk n, right? So that's from your front tower to the 2 tower. Also, you also can see here the difference between the C++ syntax and the Java syntax. They are very similar, just a little bit different. So then we just need to display to the console to show I move the disk n. Right, so then again, after you move the first n-1 from front to the assistant tower, so then we move the bottom one, the n, to the location. So then right, we just need to call this function again. We call the recursive function again. We still move n-1. But this time the n-1 actually is star earlier your destination. That is assistant tower. So then this time I need to go to the real location, 2 tower. Then I'm using the front tower as my assistant tower. Then this one is your move disk recursion function to show you how to solve the Tower of Hanoi problem. We have the if-else statement to direct to the base case or to do the recursive function code. So let's see how to really run this program in the source file. So this one is our move disk recursion function. So that's our prototype. The first one is your how many disks you want to move. So then we have 3 characters to represent, the 3 cards to represent the 2 tower, the front tower, 2 tower, and the assistant tower. So this one is our recursive function earlier we showed you. You have if-else statement to display how to move the disk. Otherwise, you will do the recursion function code and move the last disk, then the bottom disk. So then you will call the recursion function again. So of course, in order to run this program in the main function, we need to ask the user. So this program will solve the Tower of Hanoi problem and display all the steps. So we will ask the user to enter how many number you want the disk you want to move. So then we just read the disk. So then we just call the recursion function to move n disk. So we just say here our beginning is tower A, our destination is B. So then we're using the C as assistant tower. So then you can try to run this program. So yeah, this one is I have the output for 3 and 4. But then that's just right away go to the IDE. I want to show you from beginning to the end. So let's run this program from the Cloud9. So we have our recursion function. So in the main function, we just ask the user to enter how many disks they want to move. So then you will see here. How about we just move one first? I only want to move one disk. So right, just move one disk. You just move from A to B, right? So that's why you see here, move disk 1 from A to B. Good. So then we continue. We see 2, how they give us the result. Right, so actually in order to move 2 disks, you need to have 3 steps. You have moved the disk 1 from A to C. So then you have your disk 2 from A to B. Then you can move your disk 1 from C to B. So that's why you can see here, we show the user how to move step by step. So on the other hand, no matter how many you want, I just give you the result. So we have the 3 and the 4 from the handout. You see, when you move 3, total you have 7 steps. So then you can see all the steps will show you. When you move 4, you will have 15 steps from 1 to 1. You can check those steps on the website to see if that's correct. And also one thing is continue. That's the reason I didn't show you the 5. Because when we see the 5, actually they can become much more. We need to have 31 steps to correctly to move all the 5 disks to the right location. So that's the tower at Hanoi. So if you noticed, actually I have the step, I didn't show you how to do that. So that's why after you see, when you're using the tower Hanoi, the result, when we add 1 disk, actually we have much more steps need to do. And also when I show you the step in the console, I also want to show you this example. Actually, I'm using the static variable for that. Because remember, we need to call the function again, and again. In order to check how many steps one by one, I need to have a variable. They never been update the value from the function. No matter I call that function how many times, this variable will continue to update the value. So did you remember before we talked about the static variable? Right. So before I told you, if we have a static variable in the function, right, they only initialize one time. Afterward, this value will keep being updated. So that's why you see, every time I want to display each step, I just need to start from this static variable, the count, start from 0. Then before I display the step, I increment my count. So this count actually just keep counting total how many steps. And also using this one in the display, I also can clear to show user the step 1, 2, 3, 4. So in the base case, we display the step. And also between the recursion function, we display the step. So that's why I also increment here. So that's how we can have the step display one by one. And this one actually is a good example. We have the static variable. So that's a good example to use the static variable. Okay, so now back to our problem. Right, so if we want to move 5, we need to have step for 31 step. So how about we just try? You guess, if I want to move 10 disks, how many steps you need to have? Well, actually, our program died. I'm using Cloud9. They don't have enough memory for me to run. So actually, they finish at step 682 because that's really a lot. So actually, let me go back to the PowerPoint file. In order to get 64 disk move, you need to do 2 to the